today we're going to be finding area of composite figure. And before we start that, I'm throwing in a couple review problems over the next couple days because this is such a short unit. Our test already is on Tuesday, so less than a week away. So you guys really have learned all of the tools that you're going to need for this unit. Now it's just a matter of using the formulas the right way. All right, so before we get started on today's lesson objective, let's just do this really quick little review. It says use the graph to solve for X. Yeah, you guys remember how to do this? Yeah. Easy peasy lemon squeezy, right? Yeah. Okay, so if my function is y equals x plus 4, right? If I look at my problems over here, x plus 4 equals 10, my equations, where's the y in these equations over here on the left? Alex?
4 is the y.
Yeah, 4 is the y, and then what else? Wait, are you saying this 4 is the y?
Yeah.
No, that's incorrect. Take a look at your function over here, y equals x plus 4, and then take a look at these problems, these equations, excuse me.
So then it would be x plus 4.
Yeah, that's your y. Your y is right here, right? Because this part is the same as this part, and y equals that equation. Okay, so for letter A, we want to solve for x. So it says to use the graph. So if y equals 10, all we need to do, remember guys, is draw a line over from the y and then draw a line down to x. So what is x in that case? 6. And you guys could just do that in your heads, I bet, right?
Yeah.
Yeah, Charlie.
This is x plus 4, so what is x 2?
X plus 4, well, in letter A, x plus 4 equals 10. Mm-hmm. What plus 4 equals 10?
Oh.
That's all right. Okay, so what is an ordered pair? Oh, think back. Think back. What comes first, X or Y? Nora? No. So we would write 6, 10. There's my ordered pair. You guys be taking notes with me, please. How about letter B? X plus 4 equals 4. What is X? Zilch, 0. How do I write my ordered pair? Ray?
Yeah.
Yes, great job. Okay. You don't know how, Calla, raise your hand. What are you stumbling on there? Because I just heard it. Okay, I heard it. I don't know how. And then so I want to like help you know how. That's what I mean. Okay, let's take a look at the first slide there. Are these composite figures? You have to write yes or no.
Wait, composite mean? No.
Take a look at your second slide. Oh, how can we find the area? Okay, sorry, I did change the notes. Okay, last year I had notes with a couple extra slides on them, so sorry about that, you guys. All right, so before we get to the area, let's answer this question and then we'll go on. Are these composite figures, yes or no? Are they figures made up of more than one shape?
Yes.
Yes. Okay, we did composite figures in 5th grade a little bit if you were a part of Singapore math. So the answer to that question is yes, because, Kinsey, eyes up here, please. Because these figures are made up of more than one shape. Like if I were to go and let's talk about the area. If I were to try to find the area of, let's say, this guy right here, how could I do that? Charlie?
Times width plus 1/2 radius. Wait, 1/2 pi times r.
Yeah, exactly. So I would find the area of the square first, right? And then I would find the area of the circle. Whoops, I need the 1/2 pi on a Wednesday afternoon. And then what would I do after I found those areas, you guys? What do you think, Ray? Add them together. Yeah, to find my actual area, I would add the area of the square and I would add the area of the circle. Pretty easy, right? What if I wanted to find the area of this guy? What would I do? Annie?
You would use area of air.
We would need to do the area of the triangle. Actually, I'm not gonna write that down, but we would need to do the area of the triangle, right? This guy right here, 1/2 base times height. Yep, 1/2 base times height. And then, which the height would be right here, because remember the base and the height need to be at right angles to each other. And then we would need to find the area of the parallelogram, which is a different ball game. We'll talk about that at some point, but not today. So it's not length times width. It's the area of a parallelogram. Basically, what you need to do is you need to find the area of triangle. We're gonna save that for another day. But the point is that we would find the area of these two shapes and then we would add them together. All right, so let's take a look at this first problem. We want to find the area of this composite figure. The first strategy that we're going to learn today is just to like look at the figures and just add them together. Tomorrow we'll learn another strategy. Or another way of looking at them, I should say. All right, so do you guys have a quarter circle there with a radius of 3 centimeters? Okay, so the first thing that we're going to do is we're going to find the area of the quarter circle. How do I do that? What's my formula for area of a quarter circle? Finn? Yeah. Oh, hold on. No, that's the same mistake I made a moment ago when I was still thinking about our quiz. But 1/4 pi r squared. Yep. 1/4 pi r squared. Good. All right. So let's go ahead and substitute. We're going to use 3.14 for our pi. What is my radius of that quarter circle? 3. Okay, times 3 times 3. All right, so let's do some multiplication here. My area is going to equal 3.14 times 9 divided by 4. You guys ready for this?
No.
Okay, start working. Yep, first we're going to multiply. We're going to do the 3.14 times 9 because we can't cross cancel at all. So go ahead and work that out on your paper. And then you're going to divide by 4. Okay, when you have it, go ahead and look up. What did I just do here? There we go. There are going to be decimal places. What'd you get? What'd you get, Tyler?
7.065.
Nice job. 7 65 thousandths. Good. Do we have a unit here with centimeters squared? Awesome. So that gives me the area of this quarter circle, but we are not done yet, are we? Nora.
Instead of doing 1/4 pi r squared, can you do 3/4?
Oh, you know what? It's just one shape. It's asking me, we want to find the area of this figure right here. It's just that this figure on the left is a illustration for you to help visualize the quarter circle and the square separately. All right, what do we have to find next, you guys? What do you have to do next? What about the square? I heard add up some straight sides, but I don't think that's going to work for this problem. Elin? Yep, we need to find the area of the square. So length times width. What's the length and the width? Go ahead, keep going. Yep, 3 times 3. So the area of the square is going to equal 9 centimeters squared. Okay, so let's take what we found earlier. It was 7 65 thousandths plus 9 centimeters squared. And what's the total area of my figure, you guys? Finn? Yes, nice job. Way to go. Okay, well, that one was easy, right? Take a look at the next one. All right, let's do something harder. Okay. Can anybody suggest a strategy for finding the area of the shaded part? Liam?
So we find the two inner circles.
Uh-huh.
The diameter being one.
Okay.
So we'll do the inside circles, or one, divided by two, and then we'll find the big circle,
Uh-huh.
and then we'll add that.
And then we're gonna add it. Well, think about it, because if we find the area of the big circle, this is what we're finding, right? The area of the two smaller circles need to be subtracted from the area of the big circle. Yep, so great job. Okay, so if my diameter is 21, right? My radius is gonna be what? 10 and a half. Or we could also do this, 21 over 2. We can start with that. Okay, what's my radius for the large circle, you guys? What is it? My radius, 21 meters. Okay, so let's start with the area of the large circle. I'm just gonna call that area large. So pi r squared. And we're gonna use 22 over 7 times 21 over 1 times 21 over 1. Notice, do you guys see the little subscripts right here where it says area L? Well, right now we're doing the big circle. We're gonna find the area of the big circle first. All right, so use subscripts to help you remember what it is you're finding. All right, I'm gonna cross off that 7 and one of the 21s, and I'm gonna end up with 66 times 21. Uh-oh. There it is. Okay. Go ahead and raise your hand when you have the area of the large circle, but try not to throw your pencils at me. Gabby, what'd you get?
Isn't it 60 times 21?
No, 66, 22 times 3. Yeah. What'd you get, Maddie? Nice job. 1,386 meters squared. Good job. Okay, now let's find the area of the small circles. Can we do this all at once? Yes, we can. We can find the area of the small circles together because there are 2 of them and they are the same size. Let me add a subscript there. Area of small circles. So what would my formula be for the area of the small circles if I want to find 2 at the same time? Ainsley? 2 pi r squared. Great job. All right. So let's do this. 2 times 22 over 7. And my r, remember, is 21 over 2 times 21 over 2, right? Okay, we are going to be able to do some cross-canceling magic here. This is not as hard as it seems. So let's do the 7 and one of the 21s. We'll divide both by 7. We get 1 down here and 3 up here. What else can I cross-cancel? Ainsley. Yep, the 2 and the 22, so that's an 11. What else can I cross-cancel? Tala. The 2 and the 2. And now I just have 11 times 3, which is 33, times 21. Oh, I bet you guys can see that that 33 is half of 66. So our answer here for the area of the small circles is going to be half of what we just found, isn't it? Okay, so what's the area of the 2 small circles together? Alex?
99.
No. Let's think about what would half of 1386 be? Nora?
Oh,
Okay, go ahead. 600 and gosh. The computer is doing its own thing today. Where did my whole bunch of work just go? Wow, well, hopefully you guys got that. I don't know what happened to it. All right, so the area of the small circle, oh gosh, being really naughty. 693 meters. All right. What do I have to do next? I found the area of the large circle and I found the area of the small two circles. Now what do I do? Annie?
1,386.
I'm trying to get back some of my writing here. 1,386. Okay. So am I going to subtract or am I going to add right now? I'm going to subtract. 1,386 minus 693. And what is going to be the area? What's Ray? 693 meters squared. Great job. Okay. Yes, Bastion.
So will always work for the two tiny balls instead of the big ball
Will equal half? I think it will. We'd have to try it with some other numbers, but yeah, I think so. All right, let's take a look at that exit ticket you guys have next. That looks like fun, doesn't it? It is an ice cream cone. All right, let me give you a hint. The area of a triangle equals 1/2 base times height. Nice memory. Okay. Our base and our height need to be at right angles to each other. So when we're talking about the height, it's going to be right here. I don't feel like, I'm not sure that you have enough information on your page there. All right, well, who can tell me what the radius is then? Who's got the radius? Charlie?
No, we do the line. 16.
Oh, I know what's wrong. Yeah. So no, Charlie, you're right. Here's what's misleading on your page. This line, these two lines right here, so that's the height, but this 16 centimeters, that's the diameter right here. But it doesn't look like it because the shape doesn't reach the edges of the line. So the diameter is 16 centimeters. So what's the radius, guys? 8 centimeters. Okay. So you're going to find two things. You're going to find the area of the triangle and the area of the circle, and you're going to add them together. Find the area of the triangle and the area of the circle and add them together. And there's, Kelly, do you have a question? Uh-huh. Yep. Base times height. The area of the triangle equals 1/2 base times height, where the base is this measurement right here, and the height is this measurement. Okay, so what you need to do is subtract the radius of the semicircle from the 32 centimeters to find the height of the triangle. What is the area of the triangle? Nora, what'd you get? Nice job. 192 centimeters squared. There it is. How about the area of the circle, Alex?
0.48 centimeters.
0.48 centimeters squared. That sounds good to me. Okay, now my area total needs to be the area of the triangle plus the area of the circle. Ray, what did you get? Nice job. Yes. You guys got it. Okay. Homework tonight, I think I need to check on just a second.